What is a higher order function? By the end of this episode, you should be able to identify them, understand why they're useful, and have some higher order functions to study and learn if you don't already know them. My name is Eric Normand, and I help people thrive with functional programming. Higher order functions play a big role in functional programming. You'll hear the term a lot, and we're going to learn about what the term is. But they're a powerful way to abstract out functionality. So let's get to it. So first, a definition. A higher order function is a function that either takes a function as an argument, returns a function as its return value, or both. So we tend to use these all the time. If you're a JavaScript programmer, if you've ever done any JavaScript, you probably use them all over the place. So many functions in JavaScript take a callback function as an argument. So any of those functions that take a callback function, those are higher order functions. Now, you might be more familiar with the kind of classical three main functional higher order functions, which are map, filter, and reduce. So map takes a function and an array or a list, and it returns an array of f the function applied to all the elements of the argument. Filter takes a function, a predicate function, and a list of elements, and it keeps all the ones that return true when you call the predicate on it. Okay, and then reduce takes a function, an initial value, and an array, and runs the function on the initial value and each of the elements in the array iteratively, and then returns the value at the end. So these are all functions that take an argument, a function as an argument. So we'll call them first order functions. Okay, where does the term come from? I don't know if there's a real origin, if this is the actual origin, but the way I like to think of it is there's the notion of the order of a polynomial. So a polynomial in math is some equation that's like 4x squared plus 3x plus 2. You could have 7x cubed plus 4x squared plus 3x plus 2. All right, those are polynomials, but the order of the polynomial is the biggest exponent on the x, right? So a third order polynomial is going to have a 3. Second order polynomial is going to have a 2 in the exponent. And so I like to look at it like that a zero order function is a function that just takes values, non-functions, just takes values and returns values. A first order function is going to take a function. A second order function is going to take a function that takes a function. So, it starts to get pretty abstract and hard to work with, but that first order level is actually pretty useful. So why would we do this? Well, if you look at the examples of map, filter, and reduce, they are basically specific use cases of for loops or recursion, perhaps, if that's how you want to implement them, that are very useful and repeated a lot. So you could write the recursion yourself, or the for loop yourself, that transforms all the elements in a map and transforms all the elements in a list and returns that new list with those the new elements. you could do that, and every time you would write the same for loop or the same recursion over and over again. What map does is it lets you not repeat that for loop and just talk about what's different. And that's nice, right? It's way less error prone to have the thing be the looping is done for you. All you have to do is provide this function. And the function turns out to be sort of the body of the list. The body of the for loop, right? Whatever you were doing inside that for loop, now you just put in a function and you pass it in. Same with filter. You could write the loop that goes through each element and checks it to see if it's greater than 10. And if it's greater than 10, it adds it to a list. If it's not greater than 10, it just ignores it. So it just loops through all the things. Then at the end, you'll have a list of all the things in the original list that are greater than 10. What filter lets you do is abstract that away, and you say, I do not need to care about the for loop anymore. There's a lot of errors that I could do in the for loop, but right now I'm just going to pass the greater than 10 in as a function, and filter will take care of the rest. And reduce is similar. So this lets us build new abstractions that help us reduce that repeated code. And map, filter, and reduce are pretty universal. You'll find them in a lot of languages, in the standard libraries, because if you got a general purpose language, these are general purpose tools. They work very well, like in any domain. But you could have some in your domain that wouldn't make sense to be put in a general purpose languages, standard library. And so you can find them and you can write them yourselves. That's the nice thing about, that's why we have to learn higher order functions, because you should be, if you're using higher order functions, you should be able to find these abstractions that can be turned into functions, and adding new features should get easier over time, because you're increasing the amount of the number of abstractions that you have at your disposal and they, each time it should make, you should be eliminating bugs, you should be making it easier to write, things like that. Okay, so we talked about taking functions that take functions as arguments, but what about functions that return a function? We don't see that so much in JavaScript. It's not so common. We tend to want to write our functions ourselves in those languages. But what would be an example of this? Well, imagine a function, a very simple function, that takes an argument and then it returns a function that always returns that argument, no matter what arguments you pass it. So it's kind of a constantly. So if you pass it 3, it will return a function that always returns 3. So it's constantly 3. Now this function that always returns 3 is very easy to write, right? You can just say function return 3, right? And you've got that. But as a little construct, it might be faster to say constantly 3 than to write out a whole function. Depends on how verbose your language is. But just that's an example of a function that takes an argument, just a number or whatever value, and it returns a function that always returns that value. That's not so useful, but sometimes it's exactly what you need. It's exactly what you need, but it's not. The reason it's not useful is because it's so easy to write that function yourself, right? But it makes a good example. Imagine another function that takes a function and returns a function that returns the opposite of it. So you pass in the function even, So is even, which says it returns true if the number is even and false if it's not. So you pass in this function is even, and it returns a function basically with not wrapped around it. So not a function is a new function, but it's calling not is even. So that's odd, right? Now, of course, this is easy to write on your own. Like you can easily do that. But when you build up a sort of a collection of these little combinators is what they're called, little functions that return or transform functions, return new functions, you can compose them. So you can do a thing that composes constantly with a not, with a whatever you want, whether do it 3 times. There's all sorts of things you could do to transform this thing. And so you're operating at this higher level. So instead of writing out the code, you're doing higher order transformations and stuff. You don't want to get too abstract. Sometimes it's better to just write it out, but it's possible. And when you get to the next level of thinking, that's where these things actually start to become very useful. I do want to say I sometimes see this as related to what in the object-oriented world people call dependency injection. So dependency injection often to me looks like it's an objects constructor that takes objects as arguments. And so you're passing in kind of the behavior. You're passing in behavior. So it's kind of like you're passing in a function. I think it's a similar idea to higher order function. That's kind of like higher order objects made of other objects that get their behavior from those other objects. So instead of referring to the objects in sort of maybe the global space or constructing them themselves, they allow them to be passed in. Okay, so let me recap the definition of higher order functions. These are functions that either take an argument. Let me start over. A function that either takes a function as an argument, returns a function, or both, because that's possible too. We use them all the time in JavaScript. So many functions have callbacks. Every time we're passing a callback to another function, that function is higher order. You need first-class functions for this to work. You need to be able to pass functions as arguments and return them as return values. Some common ones that you might know: map, filter, and reduce. I call these the 3 functional tools. They're kind of like your basic tool set for doing functional data transformation. Higher order functions help you build new abstractions. Notice you don't need to have a lot of the constructs of your language, like the syntactic constructs, can be rewritten in terms of higher order functions. That's something to try. Try to write a conditional, like a function called if. I know you probably can't call it if. You can call it myIf, that takes a Boolean and 2 functions, one for the then and one for the else. Give it a shot. See if you can do it. You can also return a function. That is something that does come in handy, but we're not going to go too deep into that. And I think it's related to dependency injection. All right. Do give that a shot. I'll give you a little assignment. Try to write a conditional function that takes a Boolean and 2 other functions and decides which function to run based on that Boolean's value. All right. My name is Eric Normand. This has been my thoughts on functional programming. You can find this episode and all other episodes at lispcast.com/podcast. And you will find video recordings, audio, and text transcripts of everything there. You'll also find links to subscribe and how to follow me on social media, how to get in touch with me. Awesome. I appreciate you being here, and rock on.